Okay, here's our third and last example for our kinematic equations. So when we go to do this one, again, I'm going to read the question. A ball is rolling up a hill at an initial velocity of 20 kilometers per hour. The acceleration is negative 5.9 meters per second. And I want to first know how long it takes for the ball to stop. Now, when I go to do this, few things. First of all, acceleration being negative makes a lot of sense because I'm rolling up a hill. Things slow down when they roll uphill. So my acceleration being negative 5.9 meters per second is super logical. Love it. And I also know it's going to be V2 will be 0 because it asks how long it takes for the ball to stop. That's very logical. Now, the third piece of information they give me is the initial velocity, right? They tell me this initial velocity of 20 kilometers per hour, which is a great number, only it has a small problem. You will notice it does not match its friends. It's in kilometers per hour and the others are meters per second. 0 isn't anything, but still. Now, here's the thing. I never change this acceleration because acceleration is meters per second squared. That means it's per second, and that's a hard thing to change. This one's super easy though, because you will remember we did this on the first day. We talked about using 3.6, our magical number. You will need to know that number by heart. Now, how do I know if I divide or multiply by 3.6? Remember, I mentioned the fact that this is kilometers per hour. Can I go very far in an hour? Sure can. So this should be a big number. In seconds, I can't go very far. So I'm going to divide by 3.6 to find meters per second because it should be the smaller number because you can't go very many meters in a second. So I'm going to divide by 3.6 and I will get 5.555 repeated. Now, when I look at sig figs, I'm going to have 2, right, because of this number. So I'm going to keep an extra one. So I'm going to keep 5.56 because I don't want to round yet. If I round too early, I actually mess up my result a little. So I want to do this. Remember, what we're trying to find here is how long does it take? So I'm looking for the time. I want to know what the time is. Excellent. I'm going to pick myself an equation. Again, I'm going to look at my list and find one that has all of the stuff in it that I need. So V2 equals V1 plus, I'm having some technical difficulties. There we go, AT. Okay, so V2 was 0. V1, remember, use your changed ones to the 5.56. I've seen people change it and then forget and use their kilometer per hour. It's very easy to do. I'm going to use negative 5.9. That negative is super important because it's slowing down. If I put in a positive by mistake, I will get a negative time, which is impossible. I'm going to move this over first. When it moves over, it becomes a negative. Because it's positive on the one side, it will become negative on the other. And I get negative 5.9 t. There we go. So when I go to do this, I'm going to take this. It's negative 5.9. It's multiply on this side. It becomes divide on the other. And you'll notice I get a negative divided by a negative. Remember, I also said how many steps you write down is up to you. You might not write down all these steps, but it is helpful for those that are watching. So I write them down. So 5.56 divided by my 5.9. I should get a decimal. Now, it shouldn't take long for a ball to go up a hill, so that makes sense. And I get 2 sig figs because 5.9 is my least number. So I got 0.942, so that's 0.94 seconds is my time. Okay, so we're going to stop there and watch the next video for the next part.